Hello everyone. In this video, I explain the morphological effects that occur after the construction of a secondary channel. We consider the situation under subcritical flow. The widening of the main channel has a similar effect, so it is also included in this explanation. The first part explains the effects immediately after construction of the intervention. The second part describes the new state of morphological equilibrium. Part 1. We consider the case of a river in equilibrium, that is, with uniform flow. The river has a rectangular cross-section with width b. The river carries an amount of water Q and an amount of sand S per second. At t equals 0, a secondary channel is built, for example, for nature development. Water is extracted. It is assumed that sand is not allowed to enter the secondary channel. The width b and the sediment transport S do not change. Only the flow is reduced in the main channel, between the inlet and the outlet of the secondary channel. How do you draw the initial water levels immediately after the construction of the secondary channel when t equals 0? The bed levels have not yet changed. Step 1. Calculate, or estimate, the water depth h1 in the intervention reach using the Chassis formula. The Chassis formula. Q is the discharge. C is the Chassis coefficient. B is the river width. I is the slope. And H is the water depth. H1 is less than H0, since Q1 is less than Q0. Furthermore, when the width of a river widens, for instance, to provide more space, the water depth, as per Chassis formula, decreases due to the increased width. Step 2. Draw the depth of the water H1. Step 3. Draw the water levels resulting from the side channel or widening. In the downstream part of the river, the discharge and transport of sediments remain unchanged. The system continues to maintain an equilibrium state, where the water surface remains parallel to the riverbed. The water level line in the reach of the intervention must be drawn from downstream to upstream, that is, from the end of the intervention to the beginning of the intervention. The water profile corresponds to M1. The total discharge is located upstream of the secondary channel. The water line should be drawn from the beginning of the intervention in an upstream direction. The water level line gradually approaches the depth corresponding to the original equilibrium. This water profile is classified as type M2. What is the morphological effect immediately after the construction of the secondary channel? T equals 0. Upstream, a water level profile of the M2 type is formed. The water depth decreases in the direction of the flow. The velocity increases. So the transport of sediments increases. Erosion occurs upstream of the intervention. In the intervention reach, an M1 type water profile is produced. The water depth increases in the direction of the flow. The velocity decreases. So the transport of sediments decreases. Sedimentation occurs along the reach of the intervention. Now we draw the changes in bed levels in the initial situation after the intervention. We start upstream of the intervention where erosion occurs. The longitudinal sediment transport gradient tends to zero upstream where the flow tends to be uniform and increases downstream. This gradient is positive since the velocities increase in the flow direction. Therefore, the value of erosion is maximum at the beginning of the intervention. Sedimentation occurs in the reach of the intervention. The longitudinal sediment transport gradient is negative as velocities decrease in the direction of the current. Its absolute value increases downstream. Therefore, the sedimentation is greater at the end of the intervention. At the beginning of the intervention, there is a sudden local change in velocity. The water depth is the same, but the flow discharge is reduced, so the velocity decreases. Reducing velocity reduces sediment transport, which produces sedimentation that will propagate downstream over time. Also, at the end of the intervention, there is a sudden local change in velocity. The water depth is the same, but the flow discharge increases, so the velocity increases. Therefore, the sediment transport increases, which produces erosion that extends downstream over time. We can observe that these interventions not only affect the reach of the intervention, but that their morphological effects extend upstream and downstream of the same. References. End of Part 1. For more information or if you have any questions, please contact via email. info@bluesadynamics.com